A list is an ordered collection of data. To create a list, first you are going to provide a square bracket. Then inside of the square bracket, we are going to provide values separated by commas. So here we have creating a list. To create a list, all you have to do is provide a square bracket. Inside of the square bracket, you provide values, otherwise known as elements, separated by commas. So I can have 1, 2, 3, 4, and 5. So this is a list of numbers. I can as well assign this list to a variable. So I can have something like nums is equal to 1, 2, 3, 4, and 5. So this is a list. Now let me create a list of strings. Perhaps I can have something like colors. Here I'm going to have a square bracket. Inside of the square bracket, I'll provide the elements or the values that make up a list. So here we can have red, we'll have blue, and we can have yellow. So this is also another example of a list. Now let's create an empty list. So we have creating an empty list. To create an empty list, all you have to do is to provide an empty square bracket. So I can have something like nums is equal to just a square bracket. So this is an empty list. Now, lists are heterogeneous in nature, meaning that a list can contain values of different types. Here we have list of numbers. This is a list of strings. A list can have values of different types. So can have something like items is equal to 1, which is a number. I can have true, which is Boolean. I can as well have something like red, which is a string. And I can even include a list inside of another list. So I can have something like 1, 2, and 3. So as you can see, lists are heterogeneous. Heterogeneous in the sense that a list can contain objects of different types. And like I said before, a list is an ordered collection of values or elements. Now let's look at this example. We have nums equal to 1, 2, 3, 4, and 5. When we say ordered, we're talking about arrangement. Each element or each value inside of the list occupies a position, and this position is known as index. So the first item in a list has a position or the index of 0. The second one has the position of 1, 2, 3, and 4. Now let's look at how we can access elements in a list. Here we have accessing elements in a list. And to do this, we use a square bracket, otherwise known as slicing operator. Now let me remove this list and provide fruits is equal to, we'll have our square bracket. Here I'm going to have apple. I'm going to have orange. I'm going to have grape. And finally, we have cherry. Now, to access any of the elements inside of this list, all you have to do is to provide the location or the index of the item that you want to fetch. So if I want to get apple, I'll provide the position for the apple, which is 0. Now let's fetch apple. And here I'm going to have fruits is equal to, first I'm going to be providing the list, which is fruits. Then I'll provide a square bracket, otherwise known as the slicing operator. Inside of the square bracket, I'll provide the position or the index. So in this case, I'm going to provide 0. Now let me print out the fruit. So here we have print fruit, and if I run this program, it is going to display apple. Now, if I want to fetch grape, I have to provide the position or the index for the grape. So this one has the position of 0, this has the position of 1, and this has the position of 2. So here I'm going to change this to 2. Now, if I run this program, you can see we have grape. Now, if I want to fetch the last item, I have to provide 3. That is the position. So I'm going to change this to 3, then run the program. And as you can see, we have cherry. Now, if I try to fetch a non-existing element from the list, I'm going to run into an error. So if I enter 4 and run this program, you can see we have a traceback index error, list index out of range. What this means is that we're trying to access a non-existing element from our list. So try as much as possible not to try accessing element that is not existing in a list. So the first element has the position of 0, 1, 2, and 3. And this type of operation is called indexing, when you're trying to access element in a list using the positions or the index. Then we have what we call negative indexing. So here we have negative indexing. In our previous examples, we accessed elements using positive indexing. And positive indexing starts from 0. So the first element has the position of 0. But in the case of negative indexing, instead of starting from the left, we'll start from the right. So the last item has the index of -1. The second to the last has the index of -2. Now let's try this out. If I want to fetch the last item in this list, which is cherry, I'm going to have fruit is equal to, I'll provide the list, so which is fruit, then a slicing operator and -1. -1 means the last item or the last element in our list. Now let me comment out this. Now I'm going to print the fruit. If I run this program, it is going to display cherry. So if you want to access elements starting from the right side, you use negative indexing. So for grape, the position is -2. So I can change this to -2, and this is going to fetch the grape. If I want to get apple, this one is -1, -2, -3, and -4. So I'm going to change this to -4. If I run this program, it is going to give me apple. So if you want to access elements in a list, you can use positive indexing starting from the left. And the first element when you're using positive indexing is 0. But if you want to use negative indexing, you start from the right. So it's a matter of preference. For me personally, I use positive indexing. But there are times when it is necessary that you use negative indexing, especially when you don't know the number of elements in a list. For instance, looking at this list, it is obvious that we have 4 elements. So if I want to get the last element, I'll simply do 4 - 1. So 4 - 1 is going to get me the last element. So if I run this, you can see we have cherry. But in a situation whereby you don't know the number of items in the list, the easiest way to access the last element is -1. So this will also fetch cherry. If you want to fetch the second to the last item, you simply enter -2. So this is about indexing or accessing elements from a list. Now let's look at slicing. Slicing is a way of extracting all or a portion of a list. So let's say we have nums is equal to 1, 2, 3, 4, and 5. If I want to extract or fetch a portion of this list, I'm going to perform an operation called slicing. So let's say I want to fetch 2, 3, and 4. To go about this, I can have something like result is equal to, I'll provide the list, which is norms. Then I'm going to provide a slicing operator. Inside of the slicing operator, I'm going to indicate where I want the slicing to start. And since I want to fetch 2, 3, and 4, so I'm going to start by indicating the position for the value 2. So this has a position of 0, this has the position 1. So our start index is going to be 1. The first value that you provide when you're trying to slice a list or a sequence is called the start index. So this is our start index. Then after this, I'm going to provide a colon. Then I'll provide the stop index. Stop index is where you want the slicing to stop. So I want to fetch this, I want to fetch this, I want to fetch this. So here we have 1 as the position, we'll have 2 as the position, and then here we have 3 as the position. So, but instead of writing 3, I'm going to do 3 plus 1, which will give me 4. What this means is fetch items from this list. That is, in this case, this list. Fetch items starting from the position 1. Here is position 1, all the way to position 4, excluding the item in the position 4. In other words, fetch me all the items starting from here all the way to this position, excluding the one in this position, which ultimately means fetch me 2, 3, and 4. Now let me print out the results. So here I can have print result. If I run this program, we're going to get 2, 3, and 4. If I change this to 3, what this means is that fetch me items starting from position 1 all the way to position 3. So what this means is fetch me items in the list starting from this position, which is currently occupied by 2, all the way to position 3, which is like this, excluding the item in position 3. In other words, fetch me 2 and 3. So if we run this program, we're going to have 2 and 3. So this is how we perform slicing. Now, if I want to fetch all the whole items in the list, I'm going to change this to 0. That is, our start index is going to be 0, which means fetch me elements in the list starting from position 0, which is this position. And I'm going to be providing the stop index. So we have 5 elements in this list. So you may be tempted to think that 4 is the stop index. If you enter 4, it will not fetch you all the whole items in this list. As you can see, we have 1, 2, 3, and 4. So if you want 5 to be included, you are going to change this value to 5. And like I said before, this means fetch me elements in the list starting from position 0 all the way to position 5. And currently in this list, we don't have any elements in this position. But because we're excluding the item or the element in position 5, we're not going to run into an issue. If you want to extract or fetch all the elements in the list, you simply have 0 as the start index. For the stop index, you are going to provide an index or a position just one above the last index in the list. So the last index in this list is 4. But because we want to include 5, we're going to do 4 plus 1. And this is how we arrived at 5. So if I run this program again, it is going to fetch all the whole items in the list. Now, another way of doing this is instead of providing 0, I can just leave it blank. This will fetch me items from the beginning all the way to the end. So if I run this, it will still fetch me 1 to 5. I can as well omit the stop index. I'll simply have just a colon. If I run this, this is going to fetch me all the elements in the list. Now I can decide to start from position 1 all the way to the end. So I can have something like this. What this means is fetch me elements starting from position 1 all the way to the end. So if I run this program, it will fetch me 2 to 5. Now let me change this back to 0 as the start index, and for the stop index, I'm going to have 5. Now we have what we call step. So I'm going to include another column and provide 2. So what this means is that I want to skip some elements while slicing the list. If I run this program, as you can see, we have 1, we skipped 2, we'll have 3, we skipped 4, and we'll have 5. Now, if I change it to 1, 1 is the default. If I run this program, it is going to fetch all the whole elements. So if you don't want to skip, there is no point entering the step value. But if you want to skip some values, you simply enter a colon and then provide a step. In this case, we'll have step 2. Now, if I want to skip 2 elements, I can change this to 3. Now, if I run this program, you can see we have 1, we skipped 2 and 3, we have 4, and we skipped 5. So this is how we arrived at this. So this is the start index, this is the stop index, and this is the step. Now let's look at how we can update or modify lists. First, lists are mutable. What this means is that you can modify the elements in a list. So let's say we have nums is equal to 1, 2, 3, and 4. I can easily modify any of the elements inside of this list. And to do this, first, I'm going to fetch or access the element. Then I'm going to assign it to a new value. So if I want to change this first element, which is 1, first I'm going to be accessing the element, which is nums, a square bracket, and the index. Now I'm going to assign it to a new value. So here we can have 100. Now let me print out nums before the modification. So here I can have print nums. Now after modifying the element, I can as well do print nums. Now if I run this program, you can see initially we have the first element to be equal to 1. Then after modifying the first element, we now have 100. So assuming I want to change maybe the third element, I can as well have something like nums, then the index is 2. Then I'm going to be assigning it to, let's say, 25. Now, if I run this program, you can see we have 25. So if you want to modify any of the elements, you access the element, then assign it to a new value. And this is what we mean when we say that lists are mutable. You can alter, you can modify, you can update a list after creating the list. Like I said before, a list is a sequence of values, and as such, we can perform loops or iterations on lists. So let's see how we can perform loops on lists. So here we can have loops or iterations. So we're going to use a for loop. But first, I'm going to have my variable. So we can have something like colors is equal to red. We can have blue. We can have white. We can have orange. To loop through this list, I can have for color in colors, then a colon. Now I can have print color. Now, if I run this program, it is going to display the colors. We'll have red, blue, white, and orange. Now, apart from using the for loop, I can as well use the while loop. And to loop through a list using the while loop, I'm going to start by initializing a control variable. So we can have something like count. And because the first element in a list has the index of 0, so I'm going to initialize count to be equal to 0. Now here I'm going to have while count is less than, I'm going to count the number of elements in our list. So we have 1, 2, 3, and 4. Shortly, I'm going to show you how you can use a built-in function to determine the number of elements in a list. So, but for now, we're going to do it manually. So what we have here is 4 elements. So in my while loop, I'm going to have while count is less than 4. So here I'm going to have color is equal to, I'm going to be providing the list, which is colors. Then I'll provide a slicing operator. And for the index, I'm going to be using the variable count. So here I can have count. Now I'm going to increment the count. So here we can have count plus equal to 1. Now I'm going to be printing out the color. So here I can have print color. If I run this program, it is going to display the colors. So what happens is that first we initialize count to be equal to 0. And as such, this is going to fetch the first element because during the first loop, count is equal to 0. Now here we'll display the color and increment the count. On the second loop, our count is going to be equal to 1. And as such, we're going to be fetching element in the position 1. This continues on and on until we loop through all the elements in our list. Now, instead of providing this value manually, I can as well use the built-in function len to determine the number of elements in the list. So let me comment out this. If I want to determine the number of elements in a list, I'll simply use the len function. This simply means length. When we say the length of a list or the length of any sequence, we're talking about the number of elements or the number of items in the sequence. So I can have something like number is equal to, here I'm going to have len. Inside of this function, I'll provide the list, which is colors. Now let me print out the number. So here we can have print number. If I run this program, it is going to display 4. So 4 is the length of this list. Now I can decide to include another color or another element. So we can have something like green. Now if I run this program, it is going to display 5. So you don't have to count the element in a list. You simply use the len function to determine the length of your list. Now back to our program, I'm going to remove this. I'm going to remove the comment. Now instead of using the raw value for here, I can change this to number. If I run the program, it will display all the items or all the colors in our list. So this is how we perform loops or iterations on lists. Now let's look at concatenation of lists. Concatenation simply means joining 2 or more lists together. And to do this, we use the plus operator. Now take a look at this example. Here we have nums 1 is equal to 1, 2, 3, 4, and 5. And here we have another list. So we can call this one nums2 is equal to 7, 8. Now, to join these two strings together, I'm going to be using the plus operator. This operation is known as concatenation. Now, I can have nums is equal to nums1 plus nums2. Now, let me print out the nums. So here I have print nums. Then if I run the program, you can see we have a bigger list. So this list is a combination of this list and this list. The process of joining two or more lists or sequences together is called concatenation, and we use the plus operator to perform concatenation. When we get to strings, you'll learn more about concatenations when we use the plus operator to combine two or more strings together. Now let's look at repetition of lists. So here we're going to have repetition. Now take a look at this example. Here I have nums is equal to 1 and 2. Now I'm going to have result is equal to nums multiplied by 2. Now let me print out the result. And so here I have print result. If I run this program, I'm going to generate a new list that repeats the original list by 2. So whenever you perform a multiplication on a list, you are performing repetition. If you look at this new list, we have 1, 2, and 1, 2. And the reason for this is because we multiplied the list by 2. Now, if I want to repeat this list 3 times, I'm going to change this to 3. Then if I run this program, it is going to give us 1, 2, 1, 2, and 1, 2. So this operation is known as repetition. You are simply repeating the element in a given list and not multiplying the individual values in the list. The next thing we're going to learn about is how to add or remove elements in a list. So let's start with adding element in a list. To do this, we're going to be using the append method, and we're going to be using the insert method. So let's start with the append method. So here we have append. Appending simply means attaching an item at the end of a list. So let's take a look at this example. I have fruits is equal to, let's say, apple and orange. If I want to add an item or an element at the end of this list, which means after this orange, I'm going to be using the append method. But first, let me print out the fruits. So here we have print fruits. Now I'm going to be appending an item to the list. And to do this, I'm going to write fruits.append. Then inside of the append, I'm going to provide the value I want to attach or append to the list. So here we can have grape. Now let me print out the fruits again. So we have print fruits. Now if I run this program, you can see this is our original list, and this is the new list after appending a value. And as you can see, grape came immediately after the orange. So if you want to append, if you want to add item at the end of a list, you use the append method. Now let me add one more element or one more value to this list. So here we can have fruits.append. Here I'm going to add cherry. Then afterwards, I'm going to print out the fruit. So here we have print fruit. Now, if we run the program, you can see we have cherry at the end. So if you want to add element at the end, you use the append method. Now let's look at the insert method. So here we have insert. Insert allows us to add element at a specific position. So let me have fruit is equal to, let me copy this list. So I'll copy and paste it here. If I want to add an element at position 1, I can use the insert method. To do this, first, let me print out the fruit. So I can have print fruits. Now I'm going to be inserting at position 1. So this means I'm going to write fruits dot insert. Then I'll provide a parenthesis. Here I'm going to be specifying the position. So I'm going to write 1. Then afterwards, I'm going to provide the value. So here we can have cherry. Now let me print out the fruit. So have print fruits. If I run this program, you can see that we inserted cherry at position 1. If I want to insert this particular element at position 0 or as the first element in the list, I'll simply change this to 0. So this is going to insert it at the beginning. And as you can see, we have cherry at the beginning. If I want to add it at the end, I can as well write 2. If I run this program, it is going to add it at the end. But the better option is to use the append method. If you want to insert or if you want to add element at the end, you use the append method. But if you want to add at a specific position, you use the insert method. Now let's look at how we can remove elements from a list. So here we have removing elements. And to do this, we're going to be using the pop method. Then we have the remove method. So I'm going to have fruits is equal to, I'm going to copy this and paste it here. Now let's start with the pop method. So here we can have pop. The pop method allows us to remove the last element in a list. So if I want to remove this element, I can easily do so using the pop method. Let's say I want to remove this element and also keep track of the element that I removed. I can simply have something like fruit is equal to, here I'm going to have fruits dot pop. This statement is going to fetch the last item from the list and as well remove the item from the list. But first, let me print out fruits. So we have print fruits. Now let me print out the fruit, which is the item we just removed from the list. So I can have print fruit. Then finally, I'm going to print out the list after removing the last element. So here we have print fruits. Now let me run this program. And as you can see, this is our original list. And this is the item we removed. Then after removing the item, this is the resulting list. So when you perform this operation, you are removing the last item from the list and then assigning that value to this variable. Currently, our list is containing 2 items, which is apple and orange. If I want to remove the last element, which is orange, I'm also going to be using the pop method. Here I can have fruit is equal to fruits dot pop. Now let me print out the fruit. So I can have print fruit. Then let's print out the list after the removal. So we can have print fruits. Now, if we run the program, you can see that this is our current list. Then this is the item we removed. And then this is the list after removing the item. Now, we can also specify which element we want to remove using the pop method. So let's look at our list one more time. Currently, we have this as our list. If I want to remove the first item in this list, which is apple, I can as well use the pop method, but this time around, I'm going to be specifying the location of the item that I want to remove. So here I can have fruit is equal to fruits.pop. And inside of the pop, I'm going to provide the index. So here I can have 0. Now let me print out fruit. So here we can have print fruit. Now if I run this program, you can see the item we're trying to remove is apple, which is the first element in the list. Now, let me print out the list after removing apple. So I can have print fruits. Now let me run the program. And as you can see, we have orange and cherry. Now let's say I want to remove orange. I'll simply provide the index for this value, which is 1. If I run this program, we'll have orange, which is the value removed. And then this is the resulting list after the removal. So this is how we use the pop method. Now let's look at the remove method. Remove method allows us to specify the value we want to remove in a list. Now let's have our fruit one more time. We have fruits is equal to this. If I want to remove apple, I can simply provide the value apple inside of the remove method. So to do this, I'm going to have fruits dot remove. Inside of this method, I'm going to specify the value I want to remove. And in this case, I'm going to type apple. Now let me print out the fruits. So here I'm going to have print fruits. Then if I run this program, you can see that apple has been removed. If I want to remove orange, I can change this to orange. If I run the program, as you can see, we no longer have orange. When you are using the remove method, you simply provide the value that you want to remove. And you have to be mindful of the cases. If I change this to capital O, I'm going to run into an error. Of course, you know Python is case sensitive. So orange with a capital O and orange with small o are two different names. So if I want to specify orange as contained in the list, I have to use small o. If I run the program again, we'll no longer have the error messages and the orange has been removed from the list. So this is how we remove items from the list. Now take a look at this list. I have nums is equal to 7, 1, 4, 2, 9. 9. I may wish to sort the values in this list in descending or ascending order. To do this, I'm going to be using the sort method. So here we have nums is equal to this. To sort these numbers, I'm going to have nums dot sort. Now I'm going to print out nums. So here we have nums. If I run this program, you can see the numbers have been sorted in ascending order. So if you want to sort a list, you use the sort method. Now, if you want to sort in descending order, that is from the biggest number to the lowest number, then you are going to be introducing reverse is equal to true. If I run this program this time around, it is going to sort the numbers in descending order. If I want to sort in ascending order, I'm going to change this to false. If I run this program, it is going to sort it in ascending order. But if you are sure you want to sort in ascending order, there is no need to provide reverse in the first place. So if you run this program, it is going to sort it for you in ascending order. But if you want to sort in descending order, then you have to provide reverse. Now the next one is the reverse method. Reverse method allows us to rearrange the order of elements in our list. So let me copy this out and bring it down. So I have something like this. To reverse this list means that I want to change the order of elements in this list. I want something like, instead of having 7, 1, 4, 2, 9, I can have something like 9, 2, 4, 1, and 7. That is reverse, changing the order of the element in our list. To do this, I'm going to be using the reverse method. So I'm going to have norms.reverse. Then I'm going to print out norms. So here we have print norms. Now let me comment out this. Then run the program. And as you can see, our list has been reversed. Now let me print out the original list. So I can have print norms. Now if I run the program, you can see this is our original list. Then after reversing the order of the list, this is now our list. So reverse is quite different from sorting. Sorting means arranging either in ascending or descending order, while reverse means changing the order of elements in our list. The first becomes the last and the last becomes the first. That is the difference between reverse and sort. Now, apart from the reverse and the sort, we can as well sort a list using the sorted built-in function. So how we'll call the sorted built-in function. So here we have our lists. Apart from using the sort method, which is norms.sort, I can as well have something like maybe I want to create a copy of this list that is sorted. So I can have something like sorted norms is equal to, here I'm going to have sorted. Then inside of the sorted, I'm going to provide the list. So here we have norms. Now I can go ahead and print out the sorted norms. So we have print sorted norms. Then this is our original list. So we can say print norms. Now, if I run the program, you can see that our list has been sorted. So this is also another way of sorting our list. Now let's look at multidimensional lists. So what is a multidimensional list? A multidimensional list is a list containing other lists. So typically, if we want to define a list, we can have something like norms. We'll provide a square bracket. Inside of the square bracket, we'll provide the elements or the values that make up the list. We can have something like 1, 2, 3, 4, and 5. So this is a one-dimensional list. We can as well have a multi-dimensional list, which is a list containing other lists. We can have 2-dimensional, 3-dimensional, and so on. So let's create a 2-dimensional list. this is a list containing two lists. So we can have something like our square bracket. Inside of this square bracket, I'm going to have a list. I can have something like 1, 2, 3, 4. Then I can provide another list. So I'm going to put a comma, then provide a square bracket. Here I can have something like 5, 6, 7, 8, 9. So this is a typical example of a multi-dimensional list. Now let me go ahead and print out this list. So here we have print norms. Then if we run the program, you can see this is our list. So this is a list containing two lists. This is the first list and this is the second list. Now, let's look at how we can access elements in our multi-dimensional lists. If you look at this list contains two elements. So this is the first element and this is the second element. So if I have something like result is equal to norms, then I provide a square bracket and provide the index. If I have something like 0, this is going to fetch me this list. In as much as this list contains its own element, this list is simply an item or an element inside of the parent list. So let me print out the result. So here I have print result. If I run this program, it is going to display the first element inside of the parent list, which is this. If I change this to 1, this is going to fetch me the second element, which is this. Now, if I want to get any element from this list, I'll simply provide the index or the position of the element. If I want to get 6, so here I'm going to have a square bracket, then I'm going to be providing the index. And in this case, I'm going to have 1. If I run this program, it is going to give me 6. So what happens is that this first slicing operator is going to fetch this list. Then this second slicing operator is going to fetch me this element. Let's say I want to fetch the value 3. First, I'm going to be providing the position for this list, which is 0. Then I'm going to be providing the index for the value 2. And in this case, we have 1. Now, if I run this program, it is going to fetch me the value 2. Now, if I want to change this value to a different value, first, I'm going to fetch the value, then assign it to a different value. So I'm going to remove the result. Then I will assign this to a new value. So I can have equal to 100. Now let me print out the norms. Here we can have norms. If I run the program, you can see that the value has been updated. Initially we have 2, but after this operation, we updated the value to 100. Likewise, if I want to change this value to a different value, first I'm going to access this list. Then I will access this value. Then I will assign it to a new value. So here we can have norms. We'll provide a slicing operator. Here I'm going to be providing the index to fetch this list. So here we have 1. Then we're going to provide another slicing operator, and I'm going to be targeting this element. This element has the position of 4, so I'm going to be writing 4 here. Then I can assign it to a value 99. Now, if I run this program, you can see that the value has been updated to 99. So this is basically how you work with the multidimensional list. And what we have here is a two-dimensional list. Now, we're going to be building a mini project. And for this project, we're going to call it Student Score Manager. For this project, we're going to be making use of the lists. We're also going to be using the while loop. And finally, we're going to be using the input function. We're going to be storing the scores in the list. With the while loop, we're going to create a loop that keeps on running until we tell it to stop. And with the input function, we're going to be collecting scores from the terminal. I'm going to start by creating an empty list. So here I can have scores is equal to an empty list. Now here I'm going to have while true. Now this is a loop that continues running until we tell it to stop. So I'm going to be prompting the user to provide a score. So here we can have score is equal to, I'm going to have input. And for the prompt, I'm going to have please enter a score. And because we're expecting a numerical value, I'm going to be converting this score to a float. So here I'm going to wrap it inside parentheses. Then I'm going to have floats. Then I'm going to be appending this score into our list. So here we can have scores dot append, and we have score. Now I'm going to be prompting the user to indicate whether they want to continue or to stop. And I can easily do this by having something like choice is equal to input. And here I'm going to have enter yes to continue or no to stop. I'm going to have this in capital letters. So have yes, and this one in capital letters, we have no. Here I'm going to have if choice is equal to no, then I'm going to break the loop. So have break. If the user enters no, this loop is going to terminate. But if not, the loop continues. Now, at the end of the loop, I may want to print out the scores. So here I can have print scores. Now let's run this program. Here I'm going to have cd document cd Python classes, and here I will have Python score manager.py and hit enter. Please enter a score. I can enter 20. Enter yes to continue or no to stop. I can enter yes. Enter a score. I'll enter 30. Then if I want to quit, I'm going to enter no. Then hit enter. Now let me convert this to integer. So instead of using a float, I'm going to be converting to int. And I'm going to put a colon here and a space. Now let's run the program again. So I'm going to clear this, then run the program. Please enter a score. I'm going to enter 20. Enter yes to continue or no to stop. So I'm going to enter yes. Please enter a score. I'm going to enter 30. We'll have yes. I'll enter 28. Then if I want to stop, I'll simply enter no. So now we have 20, 30, and 28 as our scores. Now you may want to find out the highest score, you may want to find out the lowest score or the average score. And to do this, we're going to be using the min and the max function. The min function allows us to determine the minimum value in a list, while the max function allows us to determine the highest or the maximum value in a list. So I can have something like print. Here I'm going to have lowest score is. Then I'm going to have min. Inside of the main function, I'm going to provide our list, which is scores. I'm also going to do the same for the maximum score. So we can have print, we can have highest score is. Then here I'm going to have max, then we'll have scores. So let's run the program one more time. So I'm going to clear. Please enter a score. I'll enter 20. I'll enter yes. Please enter a score. I'll enter 30. I'm going to enter yes. Then let me enter 40. And this time around, I'm going to enter no. So our lowest score is 20, while the highest score is 40. I can as well decide to determine the average. So here we can have average score. But first, I'm going to be determining the length of the list, which is the number of items in the list. So can have number of scores is equal to len scores. To get the average, I'm going to be summing up the scores and then have them divided by the number of scores. And I'm also going to be using the sum function. So here I can have average is equal to, here I'm going to have sum. Inside of the sum function, I'm going to provide scores. Then I'll have it divided by number of scores. So here we have number of scores. This is going to determine the average score. Now I can now print out the average score. So I can have print average score is. Then I'm going to provide average. So let's run the program one more time. So have enter a score. I'll enter 10. I'll enter yes to continue. I'll enter 20. Enter yes. I'll enter 30. Enter yes. Then finally, I'm going to enter 40 and then no. Lowest score is 10. The highest score is 40, but we'll have a trace back here. And this has to do with the name I provided in the sum function. So I entered score instead of scores. So let's run the program again. So enter score, I'll enter 10. I'll enter yes. Enter score, I'll enter 20. I'll enter yes. Enter score, I'll enter 30. And this time around, I'm going to enter no. Then as you can see, this is the scores. The lowest score is 10, the highest score is 30, and the average score is 20.0.